Hello and welcome to the Module 3. First part, TCP/IP. Here you will learn the basic of the TCP/IP protocol. One usual model to describe the function of a protocol into a system is the OSI model. This model tries to standardize all the functionality of a protocol. The model has 7 layers: physical, data link, network, transport, session, presentation, and application. In real implementation, not all layers are present, and one protocol can cover several layers. Also, due to stacking protocols, some function can be duplicated on the protocol stack. TCP/IP are in fact two different protocols, commonly used together. IP protocol is considered a network protocol. It's responsible of tasks like routing, addressing, or traffic control. TCP is a transport protocol. It's responsible of reliable packet transmission. Examples of its tasks are multiplexing, retransmission, or reordering. An alternate protocol to TCP is the lesser-known UDP. UDP protocol is a lightweight transport protocol for applications where speed is more important than reliability. An IP message has the structure shown in the figure. For example, we can see source and destination addresses. Once the package is sent through the link layers, the protocol implementation is responsible of searching the correct path so the correct package arrives at its destination address. This function is usually implemented in routers and other network middle points. Address has the form of 4-byte numbers such as 127.0.0.1 or 168.27.0.1. The increasing number of devices connected to the internet has made this address a scarce resource. This has led to the introduction to a new IP protocol with a lot of new features. One of them is longer addresses. But if you are an internet user, you will notice that IP addresses are not the most common way to refer to a server or resource. Domain names like www.google.com or so are managed by an application layer protocol called Domain Name Service. This protocol manages a group of servers that are loaded with a long list of domain names and their corresponding IP addresses. They act like big yellow pages book, so people don't have to remember long lists of numbers. The IP protocol provides a communication channel between two endpoints. This channel must be shared between several applications. This is where TCP protocols comes into play. TCP provides a channel with a multiplexation mechanism called ports. When sending a message from one application to another, we specify the IP addresses and also the port opened by that application. This ensures that the message sent to the mail server are not received by the web server or other application using the same IP address. Port numbers can be any number from 0 to 65,000. However, there is a de facto standardization for these numbers, and common services have a designated port. For example, web services run on port 80, mail on port 25, FTP on port 20 and 21, and so. This doesn't mean that we cannot run a web server on port 1245, for example. This means that people expect the server to be on port 80, and if we open it on port 1245, we must inform them and make this port number explicit somewhere. TCP is also responsible to ensure that all packets reach its destination and that they reach it on the same order that they were sent. To do this, the protocol marks each packet with a sequential number and uses it to request retransmission and reorder the packets. Also, TCP is a connection-based protocol. This means that the communication should be started and ended in a predefined manner. This allows the system to detect disconnections and inform the application level so it can manage the situation. In this lesson, we have seen the basics of the TCP/IP protocol. We have seen what is an IP addresses and what are TCP ports. In the next lesson, we will see how the protocol is used together with an application protocol to complete a certain task. Thank you and goodbye.